Hey TikTok, let me show you some of my favorite apps on HoloLens too. The games, Keep Easy Escape, Microsoft Mesh, Galaxy Explorer, Surfaces, RoboRay, and which app should I showcase first? Hey TikTok, let me show you some of my favorite apps on HoloLens too. The games.
Okay, Galaxy Explorer.
Let's start your journey by pinning the Earth in the center of your room. Great! This is our home. But we are a small part of a bigger picture, which is a small part of an even bigger picture. The Milky Way galaxy is made up of hundreds of billions of stars and solar systems. You can learn and explore by looking around and selecting things that interest you. Our solar system. This familiar representation of our solar system simplifies sizes and distances so that the sun and all of the planets can be easily seen at once. Click the view button above the sun to toggle between this and the more realistic view.
Which planet should I go to first? All right, here's the sun.
At about 4.6 billion years old, the sun is an enormous ball of hot plasma, more than 100 times the size of Earth. About 5 million years from now, the sun will transform into a red giant and expand to engulf Mercury, Venus, and possibly the Earth.
Well, that's disheartening. Mercury.
At about a third the size of the Earth, Mercury is the smallest planet in our solar system and also the closest to the sun. Temperatures on the surface go as low as minus 173 degrees Celsius and as high as 427, or about 800 degrees Fahrenheit.
Sick.
Venus is nearly the same size as the Earth, with a thick atmosphere made up of mostly carbon dioxide, leading to temperatures averaging about 460 degrees Celsius. On Venus, it rains sulfuric acid, making it a less than ideal vacation spot.
Yeah. Okay. Let's see, we did Mercury, Venus, Earth.
Earth, our home. This planet orbits in what is called the Goldilocks zone, which means that it is just right. What makes it just right is that it's at a distance where water can remain liquid on the surface, which is critical to the formation of life as we know it.
I need to scratch my eyebrow. Okay. So we did Mercury, Venus, Earth, go Mars.
Mars is slightly warm than half the size of Earth with a very cold atmosphere. While today the liquid water is at the surface, astronomy features suggest that it once had large-scale bodies of water. At the poles, you can see dry ice caps. Those aren't water, but rather frozen CO2.
Nice. Oh. Mars. Next one must be Jupiter. Wait, Mars. Yeah, it's gotta be Jupiter.
Jupiter is almost 2.5 times more massive than all of the other planets combined. Look around and find a large red spot on Jupiter. That's a storm so large that it can contain multiple Earths and has been raging for hundreds of years.
Wow. That's it right there. That's the big storm. Let's see, after Jupiter, Saturn.
Saturn is best known for its beautiful ring system, which is mostly composed of particles of ice as well as rocks and dust. The planet's pale yellow color is due to aluminum crystals in its upper atmosphere.
Yeah. Nice. Jupiter, Saturn. Oh, let's go to Uranus.
Uranus is unique in the solar system due to the tilt of its axis. It's theorized that a massive collision billions of years ago tipped it on its side, leaving the poles where the other planets have their equators.
It's pretty cool. Let's see, after Uranus, we go to Neptune.
Neptune's orbit, on average, keeps it 30 times farther than Earth from the Sun. Temperature at Neptune's core is quite hot at about 5,000 degrees Celsius, while its outer atmosphere is extremely cold, approaching minus 220 degrees Celsius.
Jeez. Last one, Pluto.
Pluto, made of ice and rock, was discovered in 1930 and was originally considered to be the 9th planet in the solar system. Pluto is small, only about 2/3 the size of our moon. In 2006, the International Astronomical Union reclassified Pluto as a dwarf planet after the discovery of other similar objects in the outer solar system.
Nah, it's a planet. Let's see, realistic view.
This is the solar system at its true scale. It is rarely represented in this way because the vast distances involved mean that the orbits of the innermost planets become almost indistinguishable, and the planets and sun become tiny specks.
The central structure of our Milky Way galaxy is also known as Sagittarius A and is a complex radio source. It's located in the constellation of Sagittarius and is hidden from view at optical wavelengths by large clouds of cosmic dust in the spiral arms of the Milky Way. Sagittarius A consists of three components: the supernova remnant, known as Sagittarius A East, a spiral structure, known as Sagittarius A West, and a very bright, compact radio source at the center of the spiral, known as Sagittarius A Star.
Hey, let's check out Sagittarius A Star. Oh, jeez, what?
One of the most intriguing structures of the center of our galaxy is known as Sagittarius A Star.
Oh, jeez. That's a lot.
Sagittarius A Star is a bright, compact astronomical radio source and is thought to be the location of a
Jeez.
supermassive black hole, like those that are now generally accepted to be at the centers of most spiral and elliptical galaxies.
Wow.
Observations of the orbits of several stars that pass near Sagittarius A Star have been used to show the presence of an unseen gravity well located near the center of Sagittarius A Star's radio emissions. These and other observations have led some astronomers to the conclusion that a supermassive black hole does indeed exist near Sagittarius A Star. Astronomers have calculated Sagittarius A Star is 26,000 light years from our Sun and has a diameter of 44 million kilometers. For comparison, Earth is 150 million kilometers from the Sun, and Mercury is 46 million kilometers from the Sun at perihelion, or when Mercury is closest to the Sun in orbit. In other words, Sagittarius A Star has a diameter roughly the size of Mercury's distance from the Sun at perihelion, but has a mass 400 million times that of our Sun.
Wow. Let's try S2. Oh, looks like our Sun.
Source 2, abbreviated S2, is a star that is located close to the radio source in Sagittarius A Star with an orbital period of approximately 16 years. The motion of S2 is useful for detecting the presence of other objects near Sagittarius A Star, including the suspected presence and position of the supermassive black hole.
Oh. Well, I just wanted that right back. So that was S2. Let's try S102.
S102 is a star that is located close to the radio source Sagittarius A Star with an orbital period of approximately 11.5 years, which is the shortest orbital period of any of the observed stellar orbits near Sagittarius A Star.
Try Trumpler 14.
Trumpler 14 is among the youngest known star clusters at somewhere between 3 and 500,000 years old. It is made up of huge, hot, and short-lived stars which shine brightly in the night sky.
Cool. Let's try NGC 1501. And I clicked on the wrong thing. Let's see. NGC 1501.
NGC 1501 is a planetary nebula discovered by William Herschel in 1787.
Oh wow.
The bright star, visible at its center, resembles a pearl at the center of a shell, lending it the popular name, the Oyster Nebula.
Nice. Okay. Crab Nebula. Oh wow, that's
The
beautiful.
Crab Nebula is the remains of a supernova which was recorded by Chinese astronomers in the year 1054. The nebula itself was later observed by the English astronomer John Bevis in 1731.
Pillars of creation.
The pillars of creation are clusters of interstellar gas and dust located in the Eagle Nebula. They were photographed by the Hubble Space Telescope in 1995 and have remained one of the best-known Hubble photos ever since.
Homunculi Nebula.
Homunculus, literally little man in Latin, is a fitting name for this nebula, which is embedded in the much larger Carina Nebula. An alternate name, the Red Spadebeard, failed to gain much traction.
Sweet, that's yeah, we did it all. Alrighty. Put that back right here. Yeah, so that was a Galaxy Explorer. A lot of fun.